What determines safe tunneling? In this lesson, we will learn about the surrounding rock pressure and arching effect. Let's take a look at a news report of a tunnel collapse accident first. A tunnel collapse accident occurred in Phase 1 of the Lay Avenue Road project in Baze. 8 operators and a watchkeeper were trapped. By 22:36 on November 16, all the bodies of the 9 had been recovered. The accident occurred on the afternoon of September 10. The collapsed mass of rock and soil piled up all over the section, and smoke and dust battered the scene. When the accident occurred, the 9 workers were involved in the erection of arch frames on the left face of the Shangang Tunnel and failed to evacuate in time. All involved parties are making every effort to assist the search and rescue. However, the geological conditions at the collapse location is complex, and there are huge dangerous rocks and cracks above the collapse section, which are easy to lead to secondary disasters. The rescue team has faced new risks and problems over and over again. The rescue progress was seriously affected. As we have seen in the report, the main cause for the collapse accident during the tunnel excavation on Lay Avenue in Baze is that the upper rock strata of the tunnel falling off the parent rock slid away and seriously damaged the surrounding rock and primary support around the tunnel. The accident eventually led to the tragedy of tunnel collapse and the death of 9 people. Analyzing the cause of the accident, we found that tunnel collapse is closely related to unfavorable geological conditions. The latter is reflected in the surrounding rock and the pressure of surrounding rock. Next, let's study safe tunneling from 2 aspects: the formation principle of surrounding rocks and the reinforcement of surrounding rocks. What is surrounding rock of a tunnel? Let's imagine, during the construction of the mountain tunnel, tunneling is like digging a long passage inside the mountain. As the middle part of the mountain is hollowed out, the surrounding rock naturally shrinks to the inside, resulting in looseness, fragmentation, and cracking. But the influence is limited in range. Even blasting excavation is unlikely to cause disturbance of the whole mountain. This approximate influence area is within 6 to 10 d tunnel diameter outside the excavation contour line. The rock mass in this range is called surrounding rock, and the rock mass outside of the surrounding rock can be regarded as undisturbed and stable. When it comes to tunnel collapse, you may think that the cause of collapse comes from the gravity pressure of all the rock masses above, while the arching effect of surrounding rock may tell you otherwise. Let's take a look at an example. If a deep buried rectangular gallery is excavated in a horizontal stratum, at first, under vertical pressure, the surrounding rock on the roof of the gallery begins to sink and causes tensile cracks. Then the cracks in the middle part of the roof spread, resulting in falling of rocks and sharp increase of vertical pressure. When most of the fallen rocks are separated from the parent rock, the upper part of the roof forms a stable arched boundary. At this time, the vertical pressure is stable and the lateral pressure increase. Then, a relatively stable natural arch is formed by the surrounding rock above the gallery. Like a load-carrying ring, it transfers the gravity pressure of the upper rock mass to both sides instead of downward. Therefore, the vertical pressure of the tunnel only comes from the gravity pressure of the arched surrounding rock. It is also known as the narrowly defined surrounding rock pressure. It can be seen that, even without dedicated reinforcement of the tunnel, arching can rebuild a new balance. Given the force characteristic, most of the sections of tunnel roof are designed as an arch. In addition, the arching effect also reveals that the surrounding rock pressure will not increase due to the increase in burial depth of the deep buried tunnel. On the contrary, tunnel collapse occurs more often in the excavation of the portal section. This is because most of shallow buried sections are composed of weathered soft soil, and it is difficult to hold an arching balance. Therefore, when designing the tunnel section and calculating the surrounding rock pressure, we must not take it for granted. We must respect the law of natural change and be a qualified engineer with a rigorous craftsman spirit and a scientific attitude of seeking truth from facts. Having known that safe tunneling is inseparable from the stability of the surrounding rock, how can we reinforce the surrounding rock? Through a lot of engineering practice, wise tunnel engineers have proved that using steel bars and concrete as supporting lining is the most scientific and effective method to support and assist the self-stabilization of the surrounding rock. This is the so-called New Austrian tunneling method. In New Austrian tunneling method, we can't seem to see the support structure inside the tunnel. Why? Let's find out from the simulation test below. Anchor rods are the first choice for engineers at present. On a simulated tunnel frame, an engineer demonstrated the use of anchor bolts. After the nuts and washers are screwed into the crushed stones, even if the frame floor is removed, the compact crushed stones can easily bear an adult jumping on the surface, with the reinforcement of anchor bolts. Anchor rods are threaded steel bars that can be drilled into the surrounding rock and fixed by nuts and washers. Anchor rods connect the surrounding rock with the stable rock mass behind the surrounding rock. It's like nailing a drawing to the wall. At the same time, these grouted anchor rods bring the broken surrounding rocks together more closely, enhancing the strength and friction between the broken rock layers, and connect the cracks and fracture surfaces in the loose area to form the overall stress of the surrounding rock. Anchor rods are rod-shaped members driven into the surrounding rock during the construction stage and are certainly invisible to the naked eye after the tunnel is completed. It can be seen that the primary support can not only reinforce the surrounding rock, but also occupy less of the narrow interior area of the tunnel to ensure enough driving space for vehicles. We should take good care of surrounding rocks and minimize disturbance to surrounding rocks. Keep the surrounding rocks and supporting structures bear the stress together, and live in harmony with nature. After learning the formation principle and reinforcement of surrounding rocks, let's consolidate the knowledge with an example. It is assumed that a deep buried tunnel of a single-track railway passes through Class 4 surrounding rock, and the depth of the loose area of surrounding rock is 4.21 m. If an HRB 400 threaded rebar with a diameter of Phi22 is used as an anchor rod for support, an M20 mortar is applied. Please calculate the insertion depth L of the anchor rod. That's all for this lesson. Let's make a summary. From the formation principle of surrounding rocks, we know that the vertical pressure in the deep buried tunnel comes from the gravity pressure of the surrounding rock. From the reinforcement of surrounding rocks, the stability of the surrounding rock can be improved by using reinforced concrete as supporting lining material. To ensure safer and more efficient tunneling, when designing tunnel cross-sections and constructing support linings, railway workers should have a deep understanding of the formation principle of surrounding rocks and reasonably apply the supporting structure system. In addition, with the promulgation of the outline for building China's strength in transport, as a future railway worker, in your future work, You should adhere to professional quality, maintain the spirit of craftsmanship, and become a knowledge-based, skill-based, and innovative versatile talent.